I'm Liangcai Cao from Tsinghua University. So in this talk, I would like to give a brief introduction on the holographic displays for AR/VR systems. So I will give a very brief introduction on uh, display technologies. So we are trying to show the digital world from the physical world and build up the connection between these two worlds. For the display technology, we have a lot of screens and also a lot of headsets. So for the near eye display, I create a virtual image in the field of the view of one or both eyes, and the glass-free displays show image instantly without requiring specific IOL. So now we have the laser projections and also have the micro LED and light field screen and holographic projection. And for the near eye display, we have a different VR, AR, and MR concept. Near eye display is viewed as the output end of the metaverse. So now there are many companies are doing the near eye display products. Even now, it's growing slowly, but it has is a second phase for the product. So we are considering the capture of the 3D real world object and trying to display of the object. And for the near eye display, we have different tabs. And here you can see we have the VR display, the computer generated environment of a virtual world. For the AR display, we have the real world environment with digital elements. So for the VR display, we see the screens here. While for the AR display, we see the real world here. And also we have the mixed reality. It's a kind of a blend of physical and digital worlds. So this is a realm for different types of the near eye display. We have the AR, MR, and VR for different applications. Another topic for the display technology is the 3D display. As we know, 2D images was 1,000 words, but the 3D images was 1 million words. So how to truthfully render the huge amount of data to viewers by real-time, high-resolution, and 3D display is now still a severe challenge for display technologies. Even we can have some 3D cinemas films, but it's just 2.1 or 2.2 display dimensional display. For truly 3D display, how to render in a big data or to do the 3D display of the data is still a very severe challenge. For 3D display, we have a different tabs. Here you can see we have the left view and the right view. So this is a kind of a binocular vision. And we can also have the lead field display. We have a screen to generate the rays of the object from the different perspectives. And also we have the volumetric display, so we can render in the voxels, the volume pixels in the three-dimensional space. And finally, we have the holographic display. Holographic display, we're using a hologram to do the optical reconstruction. So Professor Daniel Smalley have a very nice review about the 3D display families. You can see we have the LED field and also the volumetric and also the holographic. So for these three types of the 3D displays, so it has a different performance in parallax accumulation, occlusion, viewing angle, and the virtual image formation. So for the near eye 3D display, so we can using different methods. So the simplest way is the binocular way in VR display. So you can see we can display immersive images by affecting binocular vision. This is the left side and this is the right side. Also, we can have a different layer of the liquid crystal screen. You can see we have the black backlight here. So for different control modulation methods, we can see the net field display. And another way is a holographic display. Holographic display means that we can have a special net modulator here, and then it can generate a 3D pattern